Hello everyone, welcome back to online NPTEL course on structure, form and architecture, the synergy. Today we are at lecture number 17 and it is all about the compressive structures. Before starting this lecture, if we just recall our previous discussions, that we have discussed about different structural arrangements and as well as different materials, and then also we discussed different kind of force acting on structure. So, based on that, like we can classify a particular structural element into category, but we have to remember one thing, that maybe a structural arrangement will have multiple such force resisting power, means the structure may also take compression as well as tension, but looking at the predominance, the most of the elements of that arrangement is taking which kind of force and resisting against which kind of applied load is basically the basis of making this classification. So, today in this lecture we will be knowing about the structure where the maximum component or the major component of that arrangement will deal with the compression force, and that is why we call it compressive structures. So, let us start that. So, at the beginning that I would like to show you this photograph that also we discussed when we discussed about the evolution of the structural system from prehistoric age to the modern age and the that present day. And this is the example of the Stonehenge, where it is basically a megalithic structures where they used this particular stone slab upstanding and they support this particular stone on top of it. So, looking at this the behavior of this vertical stone, basically all the dead load of this, all the load of this particular stone being transferred through this stone slab and it is transferring to the ground. So, in this case, this kind of arrangement where this external force is trying to compress any object, we know that this behavior is called compression, and the stress developed here is again the compressive stress. So, we can say that these elements like this particular wall, you may say or maybe the extended column, we can also say depending on the position, they are basically the compressive structures. And this is like a very basic structural arrangement, the wall slab kind of relationship is there, but in now in the modern age also we also go for this kind of compressive structures. Basically we will see in the subsequent slides that for compressive structures you use the masonry or concrete as material, and the use of this kind of compressive structure was so prominent in Greek and Roman architecture and later on even in the Gothic with the flying buttress and all. So, we will have some slides on that, we will discuss to that. Now, to start with the structure on which compressive load are applied along the length of the structure. So, we also discussed in the lecture that the principal axis, the major axis, based on that whatever the load applied on that. So, the material depending on the density and the strength and the hardness, they will react to that. So, in this case also this is the major axis, in this case this is the main axis, and the load applied to it is basically giving some compression. So, all these particles, if we consider at that micro level, that they are trying to compress, they are coming close to each other. So, basically compression taking place, and that in kind of structure, compressive structure, we predominantly see that the load is compressive load. Then along with that buckling is one of the major problem that occurs in the compressive structure, which depends on the bending stiffness and length. What exactly the buckling? So, if you can recall that we also discussed that whenever like you have a long column, so applying load on it initially it will try to compress, but if it is having higher length, and consider in comparison to the cross section. So, also we referred that as your slenderness ratio. So, basically that is the ratio between the cross section and the length of the structure. So, if it is too narrow, suppose the length is quite much more higher than the cross section, then applying the load along with the compression, it will give a bending. So, this is called buckling. So, for compressive structure, this is a problem if you have poor in this slenderness ratio. When compression load acts on short column, so basically that time crushing happens. So, it will try to compress and more, and when it is applied to the long column, then buckling will happen. So, what is short column and long column? So, short column is depending on the height, and then long column is again is basically the ratio. When we have quite much higher length compared to the cross section of that, then we refer that as a long column, and short column is just where we get something the proportion between the length of the column and the cross section of the column, they are not that much having the ratio higher than that. So, in that case, suppose roughly consider, so we can consider this as a very short column, and maybe something like that this is little bit a long column. So, you can see that though the cross section of these two thermocol that I have is same, but the length that differs. Now, the action of crushing, when we apply load on top of it, it will try to compress, and then this is basically result in for the higher load, it will go for the crushing. So, whenever we do the test with the concrete block, the compressive stress, so we will develop we will see those kind of development of cracks and it crashed. But when we apply for a long column, where again I am repeating that when the length is quite higher, like proportionally higher than the cross section of that. So, then applying load, you can if you see carefully that when I applied load on it, so it will try to bend. So, first it compress, then it will try to bend. So, this particular property is called the buckling. So, if our material is not having good stiffness and also buckling failure will be the problem. So, we have to take care of that. Now, we all know, so just to have a recap, what is compression? Compression is the ability of a material to prevent structure against pushing load. So, whenever we push the load, both the cases, one is from the upright direction, and we can also put from this horizontal direction. So, these are the compression. So, then based on this initial discussion, what we found? So, whenever we have say short column, so then if we apply load, it will get shorten, and then finally it will crush. So, crushing is your phenomena, but when you have something like this, where maybe you have very thin cross section, and then this is something like a very long column. So, when you apply load on that, it will try to bend. So, buckling will happen. So, depending on that position and that particular principle, so we have to select our structure accordingly, so that it will sustain again the applied load. Now, to discuss more on that, the simple compression occurs when the particles of material pushed against each other, that we say that they are trying to come close to each other. A supporting column is one of the example, which is basically under the compression. Compressive shortening is proportional to the load per unit area. So, and that is why now buckling will happen. When you have like very small area, so then stress will be even more. So, we know that it is A by A. So, definitely cross section will play a role. So, compressive shortening takes place along the longitudinal axis, definitely, like when it applied. So, most commonly it is to be done through the center of this particular member. Now, here we have to give images. So, it is basically showing what we said, that in a compressive stress, that how cracks develop. So, after compression it will go to the ultimate stress that it can hold, and then after that it will break. But the other case, if you see, this is a kind of example of a long column where you have like quite more length compared to the cross section, and then on applying load. So, it will have a buckling. So, in this it is your buckling, here it is crushing. Now, move forward to the material that being used for that. One is the masonry. So, masonry here, this is a representative picture where brick being laid on the cements and mortar, but like we also discussed previously, that masonry can also be done with the block, stone block. The mortar can be lime Roorkee mortar, or nowadays after invention of cement, it is cements and mortar. Concrete without reinforcement, here it is basically I am talking about the plain concrete. So, plain concrete is having good compressive strength. So, if you use a concrete block, so it can really give you enough strength, the compressive strength. But sometimes for like some high rise structure where the span is more or the height is more, then probably simple concrete will not really take that, because then as we discussed that because of the centerness ratio, because of the height of the structure, so buckling will occur. So, then in order to prevent that bending, okay, we also need some support to control, to resist against the tension developed during this bending. For that, this concrete is not good, and that is why we add steel to it as reinforcement, which is good, steel as a material which is good for taking tensile load, and then the combination of both can really do some good support that we that can give us good support to make more number of story building and make our structure more shape. So, that is why the masonry and concrete, they very good are in compression, but poor in tension. So, use of steel is for that reason, to make a balance between carrying compression, which will be taken care of by concrete itself, and then the tension will be taken care of the steel member. Now, if you see the application of that, then as I mentioned in the beginning of this lecture, that in Greek and Roman temples and assembly halls, so use of these compressive structures are very predominant. Nowadays also you can see those few of those historic buildings, still they are of that standing, and you can actually refer to them. Then after that, also in the Romanesque and the Gothic architecture, where normally for the church and cathedral they used this as a buttress and all. So, these are very predominant. Later on, like it is shifting towards the steel or the reinforced concrete structure. So, not purely the compression is basically then taking care of the other force as well. Now, if you broadly classify like compressive structure, so like we can have wall, arch, flying buttress, barrel vault and dome. But again I am telling you, like looking at the major elements of that system which is acting in the compression load, or which is resisting that compressive force, based on that this classification has been done. But at the same time, if you take example of the dome, so dome also, it is not really that everywhere will get this compression. Mainly when we discussed about the dome, we will find that this compression is basically tracking for this meridian, and when we are taking care of these hoops, so tension and compression both will develop. We will come to that only when we have this kind of system in detail. So, come to the wall, like wall may be used as a building envelope, or it may be a load bearing wall, or maybe a boundary wall. But basic principle is that like the load is transferred vertically through the axis, and this particular portion is in compression. So, in this case there is no such tension. So, majorly it is in compression. So, it is one example of the compressive structure. Here also if you make load bearing structure, the load of this slab is transferred to the wall to the foundation. So, this is another example that already we discussed earlier. Again we are taking this example of the load bearing wall normally being used, like in some of the old buildings where you have a higher thickness of the wall, and wall will take the maximum load, because then now we shift to the frame structure where the concrete columns and beams are primarily taking the load and walls are being used just to make the partition. So, in this case wall act as a compressive structures and taking the load. Now, this is another example, like this is the load bearing structure made. So, the slab, the load of the slab being carried by this wall and this transferred to the the foundation. So, this is another example of the compressive structure and wall. Come to the arch, it is very useful structure, and the use of this arch is basically spread in various type of construction. So, here you can see this is just being used for a bridge, and in many historical building that has been used to create the huge door or sometimes the corridor. So, in this case also, like if you take the arch as a component, we will also have a detailed lecture in upcoming detailed lecture planned for this whole course on arch. There will try to know different kind of arch construction and all, but in this case in short, if I say that in the arch form it is mostly semicircular in this particular form, and it is symmetrical. So, the main stone that also we refer as a keystone. So, whatever the load applied on the surface, so they actually spread over that, and that create compression and they transfer it to the support. So, this is the overall transfer of the load to the arch, and the load that being carried out is fully compression. So, in this like arch is the very good example where uniform compression we can see, and there is no bending on that. And sometimes the second line of this particular slide, that little or no tension, it depends. Suppose if we link this particular arch, the support. So, basically if I try to put the pressure. So, you just do this thing, like you just try to make one arch, okay, and you just use something, the rubber band or something like this. So, the moment you put the pressure, so it will try to be flat, and then it will elongate. So, basically, so when you press it, so it will elongate. So, here tension will be developed, but in this case there is no such attachment. So, it is full compression. So, sometimes also in some truss where arch being used, so we get this particular tension. This is again another beautiful example of the arch, how it being formed, and the main beauty is with the symmetry, and that is why like it will also make the structure in equilibrium, so that how they distribute it in the supporting structure. Now, come to the other category that we mentioned in the Gothic cathedral and all, the use of the flying buttress. So, basically it is something like you have the main structure and someone is giving you the support. Okay. So, something like that, one has to hold it. So, the load of the roof and the wall is being transferred to the flyer, and then you have another supporting wall which together making the flying buttress, it is again in compression. So, it is something you can say that having relation with the wall, and but you have a connection with the fire, so that it will transfer the load. So, you can see here also like how this particular load bearing structure being again supported with a huge mass and with the flyers. So, the flying buttress in a Gothic cathedral transfer force of compression from roof and wall down to foundation. So, basically whatever the load is there, that to transfer to the flyer and then go down and finally transfer to the foundation. So, this is very important kind of compressive structure being used in those cathedral and all. Now, in this case, this is another example, like earlier it was just a symbolic one. Now, you can see that in this cathedral how it is been made. So, this is the main structure, and then now you have this flyer, and then down to that this is connected with your buttress. Okay, so, how it is being supporting this building. So, this is again very useful compressive structure being used, and if you just consider like the building materials. So, basically either stone block or the bricks they being used, and masonry was the technique. So, they put the bricks one by one in the mortar bed and then they create this kind of structure. Now, next to that is another kind of compressive structure is your barrel vault. So, in barrel vault normally it is something that you can say that this is a stretched arch form. So, previously we have seen that arch, it is a compressive structure. So, it will have a thickness, and then if you try to stretch it, so basically that will give you another, like what we can say that hollow semi cylinder kind of form. So, suppose you just have a cylinder, okay, hollow cylinder, and you just cut it like this or maybe like this. So, whatever the form you will get is basically your barrel vault. Now, here also, as because it is having similarity with your arch, so the transfer of load through compression. So, whatever the load applied on it, so that will be transferred to the support. So, normally it is being supported by some wall, some load bearing wall and all, normally being used for making corridor and used as a rooftop in many of the buildings. So, a continuous arch shape or maybe the stretch arch, whatever you can say in this, that may approximate to a semi cylinder in form. So, we are talking about this much as a semi cylinder and it is being supported to the wall, typically formed by a series of arches. Yeah, definitely it is a continuous series of arches that is making this form, and it is the compressive structure on that nature. Now, if you see that how beautiful beautifully you can use that, and here also you can see some ornamentation, but looking at the point of the construction. So, it is again being supported and to this particular beam and then being this support. So, now the advantage of creating this, yes, you can create some span, and definitely this is one of the vaults type that we discussed, barrel vault, but there are other kind of vault where you can use to multiple such barrel vaults to form a different kind of vaults. We will also have a discussion on the vault section. One particular lecture will be on that aspect. So, then we will see that how different kind of vaults acting together, but considering the compressive full like maximum of the structural component which are dealing with the compressive force. So, barrel vault is one of them, which is extended arch form, and then that transfer the load to the support in where there is no tension or maybe very minor tension somewhere where it is being attached or closed. Now, that was one example with many structural ornamentation, but if you see this is another example of that vault where it is very nicely been done by the architect, where you can create a very smooth and a very good span management you can do with application of the barrel vault, where you can simply make something like hanger kind of support or something. So, that can give you this advantage of putting this. So, the compression is the main force which are taking care of. And now come to the other category, that is the dome. So, earlier in the vault what we have seen, that is extended, the series of arches they form that barrel vault, and here it is basically a hollow semi spherical structure, but it we can say the evolved from arches. So, what is evolved? So, if you have one arch, okay, and you axis, so you just give a rotation, okay, give 360-degree rotation of this string. So, it will basically give you, okay, the multiple arches starting from each other. So, will give you the form of this dome. And as because the basic fundamentals with the arch that we started with this discussion in the previous slide. So, there the main the load is of compression type. So, here also it is the same, but in this case what as I tried to mention, that when you have this dome. So, whenever you take this meridional stress. So, in this case it is in compression. So, they are trying to get very close to each other. So, in this case if you see that this is compression, but at the bottom they will try to go out from each other. So, in their hoops the tensile force being developed. At the top, when these particular hoops are try to get closer, so compression takes place here. So, in this case dome, if we just take as example, so majority of that is basically the compression, but slightly definitely at the circumferential hoops they are taking tension in that, and at the top where they are close together. So, then circumferential hoops they are taking your compression. So, this is again a very useful structure, but earlier when it was used specially for making a small hut or a rooftop, but now because of some improvement in the material, then use of the steel as reinforcement. So, this expanded at like in a big structure. So, not only to cover a top of any particular room or part of the building, it is basically can cover the whole lot of building or the entire area and create beautiful columnless trays on that. So, this is another example. This is basically a gymnasium for a school, where you can see that RCC dome, how it is being used to cover a huge span. You can imagine taking this as reference of the car width. This is a huge span being used, and it is not the case like being used in the present day, but also we have seen this kind of use of dome in the history. So, this is basically the example, and this is very rare view. Normally I have referred this building specially, but not this view most frequently. So, this is basically the Pantheon from Rome. So, in that if you see that from outside, so again it is giving this particular form of the dome, which is being constructed taking some good framework, and the concrete was used to make this dome. So, this is again another good example of the compressive structure. So, here it was used in the Roman architecture, and the earlier example that I have shown you. So, this is in the modern age. Definitely the earlier one only with the compression or compressive material with the concrete only, but here the steel, use of steel and the reinforcement made it successfully implemented for the purpose. Now, if you just make a summary quick recap. So, what we have learned, that compression is basically it is acting to the main or major axis where the load applied to it, okay, this is the base, and then load applied to it is basically try to compress it, try to crush it. Whenever you have like a short column or something where the considerably your length of the column is not that much bigger than the cross section. So, crushing will take place, and in place of that if you have a larger height and compared to the base, then buckling will take place, and then based on that also we discussed about the different types of compressive structure. So, we started with wall, then the arch, then the stretched arch as vault, especially the barrel vault, and then we also discussed about the flying buttress being used in those Gothic cathedrals, churches. So, basically these are the type where again I am saying ki the load they are taking, the major component of this kind of structural system are taking compressive load, that is why they are categorized in this compressive structure group. And last but not the least that we discussed about the dome, and depending on the material and the technology we can also vary the span of the dome, where mostly it is taking the compression, but definitely at the circumferential hoops they are taking tension as well. So, here we conclude this particular lecture, and these are the starting materials that you can go through, and also you can go through those website links that I have given in respective pictures. So, study more about that and can give me some feedback on it. So, next we will be discussing about the tensile structure, where again like similar to the compressive structure. So, here also the structure will discuss, mostly they will be taking tension, either they will take like a little bit compression or no compression. So, we will be discussing that in the next lecture, and thank you all for taking part in this particular course.